All right, so let's go ahead and take a look at this one. So I'm going to move this 3 to the exponent here. So f of x is equal to x cubed minus the ln of x cubed. So my derivative, f prime of x, is equal to 3x squared minus 1 over x cubed times the derivative of x cubed, which is 3x squared, because of chain rule. Remember, I told you chain rule can come back. So now what I have is my x's cancel out there. So I have f prime of x is equal to 3x squared minus 3 over x. Don't get like all weird. I want you to find a common denominator. So this is 3x cubed minus 3 all divided by x. So where is the function decreasing? Well, I'm going to have to set this equal to 0. And this is what I talked about in class. I can get a situation where my critical numbers can occur at places where it makes the denominator equal to 0. So all of my critical numbers are negative 1, 0, and 1. So when I do my interval test value, sine of f prime of x, and conclusion, I have my negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. You know, so I have x is equal to negative 2, x is equal to negative 1/2, x is equal to positive 1/2, and x is equal to 2. When I do this, and it would have been nicer for me to have this as a factored version. So let me have f prime of x as a factored version. So 3 times x minus 1, x plus 1 over x. Okay, so negative 2, that's a negative, negative, and negative. So 3 negatives make a negative, so f prime is less than 0. 1/2 would make a negative. No, it would make a positive. Just kidding. Because I'd have negative, positive, negative, so that's going to be a positive. Then f prime is going to be negative, and then f prime is going to be positive. So it will be decreasing here and here. So 0 to 1. We need to talk about absolute maxes and mins, which we will do here. So essentially they're the exact same thing. So I'm going to take the derivative. So f prime of x is equal to 3x squared minus 6. So 0 is equal to 3x squared minus 6. Factor out a 3, so 0 is equal to x squared minus 2. Just kidding. So x is equal to plus or minus root 2. And then because I want absolutes, I'm looking at what f of negative 3 is, what f of negative root 2 is, what f of positive root 2 is, and what f of 2 is. So f of negative 3, so negative 3 cubed minus 6 times negative 3 gives me a negative 27, and then plus 18, which is a negative 9. Then I get negative root 2 cubed minus 6 times negative root 2. So then I get a negative 2 root 2 plus 6 root 2. So I get 4 root 2. And then I have root 2 cubed minus 6 times root 2. So then that gives me a 2 root 2 minus 6 root 2, which is a negative 4 root 2. And then a positive 2. So then I get a 2 cubed minus 6 times 2 squared. So then I get 8 minus 24, so I get a negative 16. So my minimum value is at 2. So I have either one of those situations. And my maximum occurs at a negative root 2. So it is C. Okay. Here again, when you look at this question, see how many more do we have? Okay, just 2 more. When I look here, I am taking a derivative, so I have an f prime of x. I have a x minus 6 squared times 3 times x plus 1 squared plus x plus 1 cubed times 2 times x minus 6. And so this is where that whole factor by, grouping was so important when we did this. Okay, so f prime of x. So here I have a common x plus 1, the quantity squared, and I have a common x minus 6. What that leaves me with is a 3 times x minus 6 and a plus 2 times x plus 1. Okay, and so I'm left with an x plus 1 squared and x minus 6, 3x minus 18 plus 2x plus 2. So I get a 5x minus 16 on the inside. So when I set this equal to 0, I get a negative 1, a 6, and a 16 over 5. Okay, so if I'm looking for a local minimum, now this is a multiple choice, so let's be clear. You're going to be super upset with me, but that's okay. On a multiple choice, I don't care that you guys don't show the chart. Okay, so I can do a number line here and identify whether or not I have a maximum or minimum. Okay, so I have essentially x plus 1 squared, x minus 6, and a 5x minus 16. Okay, so when I plug in negative 2, that'll be a positive. When I plug in 0, that will be a negative 2. That will also be a positive. When I plug in 1 in here, that will give me, let's see, I'm going to make sure I'm doing this right. 16 over 5, I can't pick 1. Just kidding. I was like, that doesn't work. 16 over 5, so this is like 3 and 1/5. So that means that I have to pick 4. Okay. So when I plug in 4, I get a negative here. And then when I plug in 7, I get a positive. So my only local minimum is at 6 only. Okay. Well, where does the function here increase? So I want f prime of x is equal to 0. So 4x cubed minus 12x squared plus 8x. So factor out a 4x. And I get x squared minus 3x plus 2. So x minus 2, x minus 1, and a 4x. And that's equal to 0. So x is equal to 0, 1, and 2. Okay, so where does the function increase? So when I plug in negative 1, 3 main negatives make a negative. That'll be a positive. That'll be a negative, and that'll be a positive. So I increase from 0 to 1 and bigger than 2. Okay, and that's it for this section.